Good morning, everyone. Am I audible to you? Okay, thank you. Can anyone tell me where we stopped in the last class? Did we discuss about free hints arc in the last class? Okay. In the last class, we have discussed about free hinge arc, and there are some few numericals also, similar type of numericals, which I have already shared with you in the class group. I think all of you got that. So all of you please go through that. There's a very simple type of numerical, same procedure. Everything is same as we earlier as we did in the earlier numerical. So let's try to do that numerical. The same thing, same procedure you need to follow. So there are bending moment diagram also three hinge arc. For that part you need to do. I think all of you know these things. In case of normal beam, with the increase at the span, the bending moment acting on the span also increase, due to which changes of flexure the beam also increase, and to avoid this we can use three hinge arc. The three hinge arc having a section at the D, we are taking a section D at the distance x from left support. This is the point. So if you need to find out bending moment at this point D, how we need to find out? Here, this is the Bm at bending moment is equal to sum of the moment in the equivalent beam minus the coordinate times of the horizontal thrust. The ordinate times of the horizontal thrust. This is the formula. How we need to find out the bending moment at any point along the hinge, along the arc. This is an arc at any point. If you need to find out the bending moment, how you need to find out, you need to use this formula. Okay. Say in our case, we are finding out at point D, we are assuming a point D at a distance x from the left support. So if we need to find out this, then we will use these things. Okay. So when you find out the bending moment, all these things, this is just say example. Okay. Just try to do this numerical. There's a question. Try to do this numerical. If you do the numerical after finding out the bending moment, when you got the final value, so you have to draw a diagram that's something look like this. Okay, this 960 is nothing but the bending moment at that point D. When you calculate it, first this is just for example. Okay, when you solve this numerical, you will come to know what is the bending moment. So finally, after getting the bending moment, all these things, you can draw this diagram. So we will move to the next topic. Okay. So we will go for the finding of the ILD for determinate and indeterminate beam. So for that, there are some few points we need to remember before that. So let's go through these points before going to the main topic. So there are few points. First is remove the constraint at the point of intersect. This means if the influence line for reaction is asked, simply start pretending the beam is no longer attached to the reaction and free to rotate it about the other side. It means what? It means it is saying that, say, if there is a continuous beam, or as if there is some fixed beam or something else, what you need to do, you need to assume that beam should beam as a free beam. There is no uh, support direction attached to it, so that you can assume that the beam can freely rotate at any point about any axis. Okay, so for that you need to remove the support. Next, what we need to do, consider the remaining portion of the beam to have infinite rigidity, that is, the beam is a straight line free to rotate above the support. Okay, for that what we need to do, we need to consider a free end is it subjected to a 1 kilonewton load in the direction of rotation. Okay, so what we need to do, we need to consider 1 kilonewton load. As we have already discussed, we are doing everything as considering unit load. So we need to consider a 1 kilonewton load, or you can say unit load at any point, okay, along the beam. So when we discuss a numerical, you will understand these things. Okay, I will explain and that also. After this, what rotate or displace the free end in each positive direction, but only enough to create a direction of deflection of 1 unit. Okay, so that we can got a deflection of 1 unit when we rotate the beam in the positive direction. Okay, let's discuss one numerical, then it will be easier for you. So this is a determinant beam. So 1 unit load is applied at a point somewhere. So there is a reaction RA RB, total length is L, we have divided into A to B. So if we find out the ILD for RA, we have already discussed how it looks like. It will look like something this. If we ILD for RB, it will look like this. Okay, this thing we have already did. So next, ILD for SF at D. If we need to find out, say this is a point D in the beam. So for that ILD of SF, the ILD for SF means shear force. If we need to find out at D, just you remember these two formulas. Below it is A by L, and above it is B by L. This A and this B. Okay, A and B. Similarly, if we need to find out bending moment, then also just remember this length is nothing but AB by L, and this angle, it should be 1 radian or 1 unit. Okay, so in case of ILD for shear force, the total deflection, that is 1, and in case of ILD for bending moment, total angle between the side is 1 unit or 1 radian. Just remember these things. Okay, deflection should be 1, and the angle between the side is 1 unit or 1 radian. So just taking an example. Okay, when we use some values, then it will be easier for you to understand. So see, we are taking some values, the length 5 meter, 4 5, this is given. So when we find out SF, just use A by L. A means in our case this is 4, and B is 1. So A by L and B by L, just use this formula, you will get these values. Okay, similarly, when you find out the bending moment also, just use AB by L, you will also get the value. Okay, very simple thing, this you can easily understand. So in case of indeterminate beam, I think all of you have understand this part. Now this is very easy part. Did you understand this? Just respond yes or no. Just go through the ones, just go through once the numerical, then you can easily understand this. Okay, let's move forward. So this is indeterminate beam. In case of indeterminate beam, the slope of the ILD are not straight line. They are some have curve. As you can see here, there is a curve portion is here. So it is not always a straight line. You may get a curve. So there's three support. It is given here. 1 kilonewton load is given. How it look like, SF and BM. Will solve a numerical. Then you will understand. Okay. Let's go through a numerical. So what is the question asking? Excuse me. Draw the ILD for reaction for support A for a continuous beam and calculate the coordinate of ILD at every 1 meter interval. Okay, so we need to draw the ILD for reaction for support. This reaction RARB for a continuous beam. As you can see, this is a continuous beam, and we need to find out the calculate the coordinate. We need to find out the coordinate at every 1 meter interval. Means the total length of this beam is 11 meter. Is it 11 meters? So we need to find out the coordinate at every 1 meter interval. Okay. So for this, as per the condition, what we need to do, we need to assume a unit load at any one of the support. Okay. So we are considering coordinate of ILD at the rate A is equal 1, means we are considering for this array, this value is, we are already considering this is as 1. Okay, this one. Okay, so we will find out the ratio. So ordinate of ILD at a distance x from C, this C point, we are going come as we have already decided this at RA the value is 1. So now we are coming from C to A, and we will find the coordinate at every 1 meter interval from C to A. Okay, so for that, at any distance x from C, it will be ILD x. So calculation of ILD coordinate at every 1 meter interval is ILD 1 to ILD 11. We need to find out this 11 coordinate. Okay, so for that, there is a formula, calculation of coordinate at any distance x. What we need to do, this formula you need to remember: displacement at x by displacement at the reaction point or point of intersect, and it is simply given by yx by ya. Remember, this ya is always fixed because we have assuming this ya as 1 unit, but this yx will be changing from 1 to up to 11 meter. In our case, in this numerical, we need to change this yx value from 1 to 11, but this ya we have already assumed as 1. Okay, so there are some steps how we need to find out. See, in step 1, calculation of the other support reaction. Other support reaction means RB and RC, because we have already assumed RA as 1 kilo Newton. Okay, you may think that why we have assumed, because we need to assume as a unit load, and we have considering everything as by as unit load, and if our assumed load is correct or not, you will come to know in the at the last. Okay, so by knowing this RA, you can easily find out this RB and RC by using the equilibrium equation. We have already did so many times. Just go through this equilibrium equation, find out the RC. Similarly, find out the RB by using this equilibrium equation. Okay, but after finding of this RA, RB, RC, one step is our over. RA we already know 1 kilonewton. RB we from here we have got this value, and RC also we got the value by solving the equilibrium equation. All of you please try to do this. Okay. Next, this is our first step. What is our next step? Our next step is calculation of moment equation. Okay. For this, what we need to do, we need to, this is a B point. Okay, A, B, and C point. We need to consider a distance x at this BC beam from C point. So here it is, as you can see here, taking moment for the line BC, this BC line, taking moment BC line at a distance x, at a distance x from C. So what is the moment? Mx is equal to 1.2 into x, this x. So you can also say this in terms of derivation, d square y by dx square equal to mx by ei. This you can also, you already know. So in place of mx, just put the value 1.2x by derivation. Do the derivation part. This is all simple derivation. I think all of you know this, how we need to do. So after doing this simple calculation, these things I think all of you know how to do this. I will not repeat this, as you have already got in your third sem, fourth sem, everywhere in mathematics, how to do the derivation, d square y by dx square. So by simply doing this Finally, you will get the equation y is equal to this 1 by e I into 0.2x cube plus c1x plus c2. Okay. So now what we need to do, we need to put the value of x0 and y0 in this equation. Okay, in this equation 1, because we are using this BC line. From C we are coming to B. So at C the distance is x is equal to 0 and y is equal to 0. So from that we are starting x is 0, y is 0. So putting x and y value in the equation, you will get n at the start and at the end. At B point, x is, what is the distance of x? You already know, this is the 5 meter from C to B. So similarly, when x is 5, y is 0, you will also get one value c1. From here you will get c2, from here you will get c1. So just put the value c1 and c2 in the equation. Finally we will get the equation like something like this: y is equal to 1 by e 0.2x cube minus 5x. Okay, this is one part. Up to one part it is over from the line BC. Next, what we need to do, we need to assume the line AB is B. So now we need to assume this line AB. So taking moment for line AB at the distance x from C, we are considering distance x now at the line at the beam AB. So again similarly, when you take the moment, just use this moment to the calculation. Similarly, again you need to do the d square y by dx square by using simple calculation. These things with step by step it is given in this notes also. You go through this. Finally we will get a equation. This equation, here you put the value of c1 and c2. No need to find out again c1 and c2, which already we have got. That value you can also directly use here, because c1 and c2 is a constant. It will come up to the same. When again if you solve also, you will come but the same value. Just put the value, you finally get a equation something like this. Okay, so now what we need to do, now we have two equations. First one is this one and this two. Y is 1 by e. Two equation 1 and equation 2. We have got two equation for line BC. This is for line BC and this is for line AB. Okay. So two equation we have already got. So now for BC, what we need to do? See, for BC, we need to put the x value from 0 to 5. From 0 to 5, we need to put the value in this equation 1. So by putting 0, 1, 2, 3, 4, 5, you will get a value of y. Okay, for this is line BC. Similarly for AB also, you need to put the value from 6 to 11 as it is. I mean from C to A, the beam and total length is 11. So as you see, from 0 to 11 we are putting the value. For AB you need to use this equation, the second equation, and for BC you need to use the first equation. Okay, by putting this value we will get some values like this. Just keep it like this. After finding out this, what you need to do, now we need to find out the ILD for at every point. Okay, from 0 to 11, as you can see table this table from 0, 1, 2, 3, like this we are going up to 10, 11. Okay, so now for this, how we need to find out? As you can know this formula, ILD at x equal yx by ya. We have already got this. I've said, let me show you once. This formula, this one, ILD at x equal to yx by ya. So in our case, now we need to replace that yx value by from 0 to 1. See, so we are starting from 0, y0 by ya. So and when y0, just put the 0 value, ya is 1, so you will get 0. Similarly, when x equal 1, what is your y value? This minus 4.8 by ei. And remember, your ya is nothing but the last value, this ya. That 11th value is your ya. because we are assuming this as 1 unit and this is our last value. So at, as you can see, everywhere it is 132. See, 132, 132, 132. Here also, why we have written 132? Because y1 is our y1 is minus 4.8 by ei, and our ya is 132 by ei will be cancelled out, so only minus 44.8 by 132 will be there. So when you calculate, you will get ILD at 1. Similarly, 1, 2, 3, 4, like that. As you can see, this is 2, y2 by y2 value is our, as you can see here, minus 8.4. So see, minus 8.4 by 132. Similarly, y3, there is my 9.6, 7.2, like that. So it's going on up to 11. At the last, see, at y11 by ya, see, 132 by 132, you will get 1, which is we have already assumed, means our calculation is correct. That's why we are getting 1 as the final value. So after getting this, you need to put this curve, put this value, just put this is your ya value 1. Similarly, 0.7858, everything whatever you got, just put. When you get 0 in that point, you see, at the intersection point you will get 0. So please try to do this. It's a very easy numerical. Just do step by step. You can easily understand and you can easily able to do. Okay. Is there anyone have any doubt? You can ask me. Okay. Until then, you all of you please give your attendance in the chat box. If anyone have any doubt, you can ask me. Okay. Did you understand all these things? All of you please try to do this. Okay. Without doing, you will not able to understand. Just try to do it by your own once. Go through the steps. It's everything is given in that PDF. So all of you go through that and try to do it. And please don't leave the meeting, okay? I have to something to say you. Please don't leave. Let me mark your attendance first. Then Are you all present here? Did you understand all these things? Okay, let me check. Are you all there physically present or just joining in the meeting? As I'm not able to hear anyone's voice. 109 is there? 109.
Yes, sir.
Okay. Then 124.
Sir, 109 is here, sir.
Okay, fine. Then 124. If someone will not respond, I will not give attendance today. 124. 136.
Sir, 134, sir.
136 present, sir.
Okay. Then 99.
Hello, sir. 061, sir.
I will call one by one. Okay. Don't respond in between. 136 is there. 99.
Yes, sir. 99.
Okay. Then 114.
Present, sir.
Okay. 133.
Hello.
133.
Yes, sir.
Okay. 108. 108.
108 present, sir.
And 18.
Hello, sir.
18. Roll number 1.
One. Roll number 1 present, sir.
You are there stepping in. Then 42. 42. 43. Okay, fine. I think all of you have present there, but I am cross checking because no one will respond when I am asking something. Are you there or not?
Yes, sir.
Yes, sir. Okay, fine. I will continue in the next class. Okay, we'll start a new topic. Okay, just wait for some time. Is there anyone have any doubt regarding this class? Today's class? Yeah, I don't think so. There is doubt. Okay, thank you. Then we'll start the next class and after some time. Thank you.